All right, so the last little bit we have to do with our basic indefinite integrals with anti-differentiation is dealing with our trig functions. You guys are going to now be able to take the antiderivative of trig functions. Here's the list here, as well as here. Let's look at it on the bigger side of things, okay? This is your integration of your trig function. So if you're given the cosine of x, the antiderivative of that is sine x plus c, and then the rest follow along accordingly. Of course, for these, for any of these, if there's like a leading coefficient, you have to take into account, the constant multiple rule, and, take that into account when you're taking the antiderivative. But pretty much these are them. All of these are in your reference booklet. Technically, they're there for the derivatives, but pretty much they are true to themselves. So essentially, these are all of your derivatives. Or these are your originals and these are your derivatives, so it goes both ways. So you technically have all of them in your reference booklet. It's just a matter of making sure that you apply all the different ways to integrate with your trig functions, and that's what we're doing today. So, looking at the first one, pretty straightforward, pretty simple. Again, as long as you know what the antiderivative is of these functions, then you'll be able to find the integral of 2 sine x minus cosine x dx. Let's break it up into pieces. What's the antiderivative of sine? Careful. Antiderivative cosine, antiderivative of sine x is a negative cosine x. So then it's going to be negative 2 cosine x. And then the antiderivative of cosine x is? It's a positive sine x, so then that minus just gets brought down, and then you have your plus c, simple, straightforward as that. All right, here we're going to take the antiderivative of 3 secant squared x minus x squared. Secant squared x is one of those functions that you can take the antiderivative of. What is the antiderivative of secant squared x? Tangent x, so that constant in front will be brought down, so that's going to be 3 tangent x. What's the antiderivative of x squared?
1/3, x a third.
So then I just bring down the minus, and then of course I cannot forget my plus c. And clearly these are some of the easier ones, straightforward trig functions, all right? Let's look at the next one. I have 2 secant x tan x minus 6 over 1 plus x squared. What's the antiderivative of secant x tangent x?
Secant x plus c.
Okay. So that'd be 2 secant x. And then let's look at that next part. I have a minus 6 over 1 plus x squared. And I can take out that 6. So that 6 is essentially like a constant. So it's really more like 6, the integral of 1 plus x squared. This straight up is arctangent. So then this just becomes negative 6 arctangent x. And then of course your plus c. Don't forget your plus c. All right, everything we've done so far has been dealing with indefinite integrals. So you have to make sure you include the plus c. Unless you're given like a point, then you're finding the particular solution. This next one. It's a little bit different. It's not like the last 3, because I have x times cosine x. We're going to do integration by parts here. Good way to recognize. What's going to be u? And then cosine x is going to equal what part? The v prime, or yeah, the dv over dx, right? So then I need u prime, which is, and then I need v. Is it sine x or is it negative sine x?
It's just regular. Oh, sorry, sine x.
It's just regular sine x, because we're doing the antiderivative of it, and the antiderivative of cosine is a positive sign. All right. So then the formula again for integration by parts is uv minus the integral of u prime.
I thought it was just regular.
It's just v, right?
couldn't remember. That's what I'm saying. I was like, help me out. All right, so here we go. I have u, which is x, v sine x, minus the integral 1, I'm not going to write that, v sine x dx. I am going to have to continue to integrate that sine x. Okay, what's the antiderivative of sine x? Positive or negative?
Negative.
Negative. So since it's a negative cosine x, the minus and that negative are going to
Cancel out.
and become a
Plus.
and there we go. Integration by parts. Fourth. All right, let's take a look at this one. Okay, I want you guys to do this one. Speaking of, find f of x.
Salad.
So we're going to find f of x given that f prime of x equals 2 sine x minus the square root of x, and f of 0 is equal to 4. So this time we are actually figuring out the equation for f of x. So you have to take the antiderivative of 2 sine x minus the square root of x. What did you guys get for that part? You said negative 2 cosine x?
Yeah, I believe so.
Negative 2 cosine x. Okay, and then what about for the next part?
Negative 2/3 x.
And then you'll have your plus c. Of course, you want to figure out what c is by plugging in 4 for f of x and then 0 for x. And be very careful. It won't always cancel out every single term. Like in this case, the cosine of 0 is putting a little bit of trig unit circle in there. So then c is going to be equal to 6. So my final answer for my function is negative 2 cosine x minus 2/3 x to the 3/2 plus 6. For Schoology and your homework, when you guys, like let's say this was your answer, you would type it in, no spaces in between anything, and any fractions, you need to make sure to include a parenthesis. And of course, you would put a caret to indicate the exponent.
So like nothing in between, like the negative plus like.
Yeah, like everything just straight through.
I decided that was probably carrot.
Me. It's not a carrot.
I'm calling a caret for her.
That's
A few more linear factors that you guys need to remember. These are not in your reference booklet. So you have one for cosine, one for negative sine, and then one for secant squared. So make sure you guys get these down. These you do have to remember. They are not in your reference booklet. So now we can incorporate these into some of our problems now. All right, let's take a look. Here we have 2 sine 3x plus cosine 4x plus pi. Both of these are linear factors. That 3x is technically that ax plus b part, and then of course here you have that ax plus b. You have a coefficient in front of the sine 3x, so it's going to be 2 times the antiderivative of sine 3x, okay? So, real quick, let me just go back. Be very careful. You see how it's negative sine ax plus b is equal to 1 over a? So if it's a positive sign, this one here would have to be negative. So I'll have 2 times a negative 1 over a, which is 3, cosine of 3x. And then over here, it's going to be 1 over a sine ax plus b. So this is going to be plus 1 over a, which is 4 sine 4x plus pi. And then, of course, I have my plus c. So my final answer is going to be negative 2/3 cosine 3x plus 1/4 sine 4x plus pi plus c. Where's the what?
I don't even know.
We're going to look at the last one, or the next one, not the last one, I apologize.
Dang it.
Dang.
All right. We're going to integrate 2 minus sine x squared with respect to x. Now, before we can do this, all right, because there's not like a linear factor that involves a trig function with it, so we're probably going to have to do what before we actually take the antiderivative of it?
What's that inside of the
Are you gonna
parentheses right next to the sign?
same one?
An x, a minus?
What was that? It looks like a T. What is it?
Boiling thought of that idea.
This is a 4.
Oh.
What should I do here?
I was gonna say foil, but.
Let's FOIL.
Right.
It's going to be 2 minus sine x times 2 minus sine x. What does that become?
4 minus 2 sine x plus sine
It's
squared.
gonna be minus 4 sine x. There's our chicken.
Okay. All right, by doing this, I am now able to take the antiderivative of 4. I'm able to take the antiderivative of negative 4 sine x, but I'm still in a situation though with the sine squared x. This is where I'm going to have a teachable moment here. There, outside the identities that we've already talked about, sum and difference, double angle, half angle, there's actually a few other ones. There's power reducing identities, product to sum, and sum to product identities that you guys aren't necessarily responsible for knowing. However, to be able to integrate trig functions like this, like sine squared x or cosine squared x, you'll need these identities that I'm going to write down here, and they would actually be very beneficial if you wrote them down and had them yourself. So you have sine squared theta is equal to 1/2 minus 1/2 cosine 2 theta. And then cosine squared theta is equal to 1/2 plus 1/2 cosine 2 theta.
And then you're double line.
All right. Granted, you do have like a double angle here, but technically you have a linear factor now, and you can take the antiderivative of that. So this becomes the integral now of 4 minus 4 sine x plus, I'm going to replace that sine squared x with a 1/2 minus 1/2 cosine 2x dx. Okay. So now I want you to take the rest of the problem and actually get my antiderivative now that I've helped you through to get to that point.
9. Oh yeah, 9.
Yeah, okay.
And
Combine.
It's a heart. Yeah, because that's 4 plus 1.
Oh, okay. That was
Mm-hmm.
Wait, they're done eating?
They're done eating.
They will never eat again.
This should have been your final answer. 9/2x plus 4 cosine x minus 1/4 sine 2x plus c.
Looks like it.
All right. Few more. Let's integrate this with respect to x. Now, when you look at these here, I have cosine cubed x sine x.
Oh.
What do you think?
Okay, so we can take a cosine squared out and then have another cosine.
Yeah. Cosine squared times cosine.
Okay. And then?
It would just be cosine squared times
No.
cosine times
Integrate.
sine.
Cosine squared times cosine.
But they're all being multiplied together.
You can do that, right?
Now when they're all being multiplied together, like if they weren't being added, you could, but
I thought you could do that integration by parts with 3.
oh, so you want to do integration by parts?
I thought that's
Well,
what you could
Tell us what we need to do here.
do.
I mean, I don't know if integration by parts. I mean, it probably does work.
Oh, I thought we were just gonna use
But-
the identities and just do
For what?
I'll still have like part of it that's still being multiplied. Every single part will still be multiplied by sine. Could it work? Yeah, I think so. Maybe.
Is that going the long way?
I think so, yeah. Definitely.
Never take the easy way out.
Now let's go the hard way.
Okay. Don't forget, we've done integration by parts, we've done basic, we've done linear factors. Which one have we not done yet? Substitution. I can make u.
Oh, yeah.
I can make u
You.
cosine x, and then I can make du.
Negative sign.
No, just be, or, yeah.
No, you're right. It'll be negative sine x, because remember this is the derivative. The derivative of cosine is negative sine x. Okay, so essentially that's going to be a negative du that gets plugged in for us to replace this. So now it becomes the integral of u to the third negative u to the third du, because I'm able to replace sine x with a negative du and then cosine x with u. So this becomes what? What's the antiderivative of negative u to the third power?
1/4 or negative 1/4 u to the 4th.
U to the 4th, and then I'm going to just plug in my u back in, and that's going to be my answer. Or I can say this is negative 1/4 cosine 4th power of x plus c. Either one would be acceptable. Try B, using U substitution. What did you make u?
Sine.
That probably definitely been the easiest route, because then that means that du is going to equal cosine x dx. So then when you go to rewrite it, it becomes du over u, which is the same thing as saying 1 over u du. So the antiderivative of that is ln
U.
of u
Absolute value.
with the absolute value bars plus c. Well, we plug u back in to get the ln absolute value of sine x plus c. And this is how you work with trig functions and the integral. Okay. Let's look at. I'm gonna save that one for tomorrow. Let's take a look at this one. This will be our last one. It's gonna be our last one today.
And then you set your u as cosine for that one.
Yeah, this would be my third time. Yeah, this would be the third time.
And it's still there.
X minus integral of v. Oh my goodness.
Well, that crosses out. That's nice. Okay.
And U substitution, is it UV minus?
You talk about substitution.
What?
She meant integration.
Oh.
Oh, what?
Did you mean
You said substitution.
I meant integration by parts. I apologize. My mistake.
I'm gonna say
I was like
Oh.
concerned.
Okay, so after all that, I got negative cosine x dx minus the integration of ex times cosine x.
would it be negative minus? Would it be minus the integration?
No, yeah, minus the integration of ex cosine x.
So it does make the thing positive. That's fine.
Back to where it was the first time. One more time. If I do it again, it's gonna go back to the original function one.
If that goes back to the original function, I will be irrevocably angry.
So look at the integral of e to the x sine x dx. This essentially is, like you said, that is the original from what we had before.
That's aggravating.
This is equal to this. Essentially, right? So what we can do from here, haven't. So what I can do is, since this is the exact same thing as what I originally started with, I could add it over to the other side.
I didn't know you could do that.
And then solve by dividing both sides by 2. So then my final answer, the integral of e to the x sine x dx is equal to negative e to the x cosine x plus e to the x sine x all over.
I didn't know you could do that.
We're in a new.
Well, that's the thing. Like you said it was going to continue to keep repeating itself over and over again. Okay, well, the truth of the matter is that once you get it back to this point, you essentially are been able to solve for that expression.
Because it's really just algebraic.
We
Mhm.
live in a society.
Let me write this down.
Yeah, definitely get this one down. And of course, don't ever forget about your plus C. Good catch.
What did I say? Oh, it's a nature don't apply. This There is no C in this.